All right, let's dive into one of the biggest hurdles in 3D printing, shall we? We're talking about how to turn that raw print, the one with all the visible layer lines, into something that looks absolutely flawless. If you've ever wanted your prints to look like they popped right out of a professional mold, stick around. We're about to spill all the secrets.
And this right here is what it's all about. Look at that difference. We're going from that familiar kind of rough texture of a standard 3D print to a surface that is so ridiculously smooth it could be a commercial product. Now, this isn't some kind of magic trick, I promise. It's a process, and we're gonna break down every single step for you. So here's our game plan. First, we'll cover the prep work that you've got to do for any print. Then we're gonna tackle what I call the PLA gauntlet. After that, I'll show you a really neat shortcut for PETG, and then we'll get to the absolute game changer, ABS. And finally, we'll wrap it all up into a blueprint you can use for pretty much any project you can dream of. Okay, before you even think about picking up a piece of sandpaper, success really starts with the print itself. These next couple of steps, they are completely non-negotiable. I don't care what filament you're using, getting this foundation right is gonna make everything that comes after it so much easier.
Look, if you want to have a solid canvas to work on, you need to give yourself enough material to play with. So in your slicer, you're going to want at least 4 walls, 4 top layers, and 3 bottom layers. This gives your print a nice thick shell so you can sand away aggressively without ever worrying about accidentally hitting your infill. Honestly, just think of it as cheap insurance for all the hard work you're about to put in. Once your print is off the bed, it's time to get rid of those supports. And you need the right tools for the job. First up, gloves. Seriously, don't skip these. The edges of support material can be razor sharp. Your flush cutters are going to be your workhorse for getting the big stuff off. Then you've got your needle nose and tweezer pliers for those tight, stubborn little spots. And a deburring tool? Oh, it's perfect for just cleanly slicing off any leftover brim or support nubs. And now for PLA. It's funny, it's the most common filament out there, but it is without a doubt the absolute worst to sand. It's just so tough, it doesn't want to grind down, and finishing it is a ton of work. We call this the gauntlet for a reason, because I'm telling you, if you can master this, you can finish anything. So what's the one tool that makes the PLA gauntlet even possible? Let me introduce you to the infamous foot sander. And yes, it is literally designed for calluses on your feet, but its adjustable speed and super aggressive grit make it the GOAT, the greatest of all time for just ripping through those layer lines. The best part is, unlike an orbital sander, you can just set it on your bench and use both hands to move the part around, which gives you incredible control. The PLA workflow really is a multi-stage fight. First, you're going to hit every surface you can possibly reach with that foot sander. Then you'll switch over to hand sanding to get into all the little nooks and crannies the machine can't touch. Once that's done, you can glue your parts together and immediately start filling those seam lines with spot putty, which, of course, you have to sand all over again. Yeah, it's a lot of work, but it's what you got to do for PLA. So what is this Bondo spot putty stuff anyway? Well, it's a really thick paste. It kind of has the consistency of toothpaste, actually, and it's used in auto body work. It is absolutely perfect for filling in small scratches and, most importantly for us, those ugly seam lines where 2 parts join together. It just helps create one single continuous surface. Okay, after all that initial sanding and filling, we bring in the filler primer. And this, my friends, is where the real magic happens. You spray on a couple of thick coats and it fills in all those tiny microscopic imperfections that sanding left behind. Then, and this is the key, you sand the primer itself until it's perfectly smooth. If you have some really stubborn gaps, you can break out advanced stuff like a UV resin mix. After that, it's one more round of primer and a final super fine sanding to get it ready for paint. Right, so the crucial thing to understand here is that filler primer isn't just regular paint. It's a thick, buildable coating. Its entire job is to add a brand new, perfectly smooth layer right on top of your sanded plastic. It's this layer that hides those last few imperfections and gives you that flawless canvas you're looking for. Whew, okay. If that whole PLA gauntlet sounds like way too much work, and trust me, a lot of the time it is, let's talk about a shortcut. PETG. It offers a much easier path to that same smooth finish, and it all boils down to one key difference.
And here it is. It's that simple. The biggest advantage of using PETG for this kind of work is that it is just so much easier to sand than PLA. The material grinds away more readily, which means you spend way less time and elbow grease on that first aggressive sanding stage. I'm telling you, this one thing alone will save you a huge amount of time and arm soreness.
The PETG process starts pretty much the same. Foot sander, then assembly. But here's where the shortcut comes in. Instead of just relying on can after can of spray-on primer, we're gonna make our own brush-on filler. All you do is thin some spot putty with acetone. You coat the whole piece with this stuff, sand that smooth, and then you just need a final lighter coat of primer, maybe using some UV resin for any tiny spots that are left over.
So what is this little hack? Well, by mixing Bondo spot putty with a splash of acetone, you basically create this thick, paintable slurry. This trick lets you apply a really heavy-duty filler layer with just a cheap brush. It gives you way more control, and it saves you a ton of money on those expensive cans of spray primer. It's like a homemade, high-build primer that you can put exactly where you need it.
Okay, so we've seen the hard way with PLA and the smarter way with PETG. Now let's look at the fastest way. ABS is a total game changer, and it's because its unique chemical properties let us skip a lot of the most time-consuming manual steps altogether.
What we're talking about here is a completely different way of thinking about the process. With PLA and PETG, the workflow is all manual, right? Sand, fill, prime, sand again. With ABS, we use chemical processes, smoothing and welding, to do all the heavy lifting, and that just dramatically slashes the time and effort involved.
Yeah, the ABS workflow is completely backwards from what we've been doing. Instead of starting with sanding, you actually start by brushing on something called ABS slurry, which literally melts the surface of the plastic and fills in the layer lines for you. Then you sand it, and I'm telling you, the surface becomes butterly smooth almost instantly. You also use acetone to chemically weld parts together, which creates a bond that's way stronger than glue. You can even use the leftover slurry to fill the seams. It is so efficient. The two ideas you really need to get are slurry and welding. ABS slurry is just scrap ABS filament dissolved in a bit of acetone. It's a totally waste-free way to make this incredible smoothing paste. And chemical welding is exactly what it sounds like. You use a solvent like acetone to literally melt the surfaces of two parts so they fuse into a single seamless piece. You're not just sticking them together, you're making them one. So there you have it. We've just walked through three very different ways to get that perfect finish. The way to think about this isn't as one strict set of rules, but more like a blueprint. You've got different paths you can choose from depending on your project, how much time you have, and of course the filament you're using. Let's just break it down one last time. PLA is your baseline. It's a ton of sanding and filling, but hey, it's the filament most of us have lying around. PETG is your shortcut, using that clever brush-on filler and being way easier to sand. And then there's ABS. That's the pro choice, using chemical smoothing and welding for what is, by far, the fastest and most efficient workflow. But here's the thing. No matter which path you take, whether it's the PLA gauntlet, the PETG shortcut, or the ABS game changer, the journey always ends the exact same way. The last two steps are always the same. A final, gentle wet sand with 400 grit paper to get rid of any dust or overspray, and then a really good wipe down with a damp cloth to make sure that surface is perfectly clean and ready for paint. And this is the final takeaway. When you really look at the time and effort you have to put in, the difference is just staggering. PLA is a massive time investment. PETG cuts that down quite a bit, but ABS is in a league of its own. To put it in perspective, you could probably get a complex part like a helmet ready for paint in a single day with ABS. With PLA, you could be looking at 2, maybe even 3 days of work. So, all of this leaves us with one final thought. You know, most of the time we choose our filaments based on how easy they are to print, or maybe their strength. But now that you see how radically different the finishing work can be, does that change how you'll approach things? For your next big project, are you going to choose your material for how it prints or for how quickly you can finish it? Something to think about.